Alrighty. This isn't the first problem. Alright, here we go. This is Unit X, the matrix sample test. The video. Number 1 and number 2 talk about solving the following systems of equations using matrices. Give the final answer as an ordered triple. And here we go. So the first thing you do is you convert this system of 3 equations into an augmented matrix, complete with vertical line right here, separating the coefficients and the variables from the constants over here. The first thing that I did was I switched row 1 and row 2, and the only reason I did that is to have a 1 in the upper left-hand spot. It's not mandatory, you don't have to, but it does make the remainder of the steps go a little bit smoother as we look to make our 3 zeros. So that's what I did first, just a quick little row switch that's definitely allowed. And so then I set my sights on turning this spot into a 0, and then also this spot into a 0. And so I'm going to need a new row 2 and a new row 3. Row 1 stays the same. To make a brand new row 2, I'm going to make a combination of row 1 and row 2. And in order to add row 1 and row 2 together to make a 0 where I want it, I'm going to use that row operation and combination, and I'm going to use a combination of row 1 and row 3 to make a brand new row 3. And in order to have my row 1 and row 3 actually add up to 0 where I need it to, I need to do that row operation. Okay? So again, like row 1 is going to stay the same. And in order to make my new row 2, I'm going to do -3 times the stuff in row 1, and then just add the stuff in row 2, the corresponding numbers, to get a brand new row. So -3 times this is -3, plus 3 is 0. And I move across the entire row. -3 times this number is -9, plus this number is -8. And then -3 times this number, this row 1 number, plus this row 2 number. So this would make me +15 plus -1, 14. And then -3 times the number in row 1 plus the number in row 2. So this would be +30 plus 10, 20. And now I have to make a brand new row 3. And to do that, I multiply all the numbers in row 1 by -2 this time, and then add row 3. So -2 times the number in row 1, -2 plus 2, there's my 0. And then as I move across, doing the same thing all the way across, multiplying the numbers in row 1 by -2, and then adding the number in row 3, I get all these numbers, okay? So there is my matrix so far. But I still have one more 0 to make, and I need to put a 0 in this spot right here. So row 1 doesn't need to change, and row 2 doesn't need to change. So we're going to stay here. But and then here's a key point. Okay, here we go. Let me pause for a second to remind you of something very, 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 very important. When you're making this final 0, it's got to be from a combination of row 2 and row 3. It's got to be from those 2 rows. Otherwise, you're going to lose this 0 while you're making this 0. Okay, it's not worth it to make this a 0 and also lose this 0 at the same time. So that's why it's got to be a combination of row 2 and 3. All right? And my combination, I did my row operation, was -1 times the numbers in row 2 because that would make this a positive 8, and then I would add whatever's in row 3 to make this particular spot a 0. Remember, you can do your own, even from the beginning all the way back to here, you can do your own uniquely, maybe subtly different row operations. It doesn't matter, as long as it makes sense and it gets the zeros where they need to be 0. We're all going to get the same final answers for x, y, and z anyway. So when I do -1 times the row 2 number, that stays 0, plus the row 3 number, hey, I kept my 0. I didn't lose my 0, like I said wouldn't happen. And then as I move across the rows, -1 times the row 2 number gets me positive 8, plus that, hey, there's my 0, just like I planned. And then I move still across, -1 times that row 2 number gets me -14, plus that gets me -1. And then likewise, -1 times that plus that gets me -2. And so that completes my whole process of getting the zeros where I want them. And as soon as I get the zeros where I want them in those 3 particular spots, I can turn my rows back into equations. And once I rewrite my equations, put the x's, y's, and z's back in there, and the equal signs and everything, now I can start by figuring out that z must equal, if negative z equals -2, I know that z equals 2. And once you know z equals 2, you can plug that back into this equation and figure out that y equals 1, right? Once I know that z equals 2, you plug it in right there. And then this would be plus 28. And then when you subtract 28 to both sides, you get -8. Okay? And then you divide both sides by -8 and you get positive 1. And then using both of these answers, both of them, the fact that z equals 2 and y equals 1, you plug it into this equation, right? So you plug 1 in for y and 2 in for z. And so you get this. And then when you, this would be a -7. And then when you add 7 to both sides to get x by itself, you get -3. Okay? So final answer, the ordered triple of x, y, z, -3, 1, 2. X, y, z again, okay? Number 2 is nothing all that different. So maybe we can burn through this even quicker. The first thing I did was I swapped row 1 with row 3. Again, it's just super nice. It's not necessary, but it's super nice if you have a 1 up here in that row 1 spot, in the upper left-hand corner. So once again, row 1 doesn't need to change. I make these 2 zeros. Those were my row operations I chose, which resulted in this brand new row 2 and this brand new row 3. And again, that was from my specific row operations. If you did a different row operation, you're probably going to get different numbers. And that's okay, as long as we end up getting the same final answers right here, okay? And once again, to make your final 0, again, we can keep row 1 as is and row 2 as is from here. We just need a brand new row 3 one more time, and it's got to be a combination of row 2 and row 3. I decided to go with this, multiplying row 3, particular this number, by -5 to make it into a positive 5. And then when I added it to the number in row 2, I could make my 0. Of course, you have to multiply the entire row 3 by -5 and add it to the entire row 2. And I get this. And it's the same song and dance. Now you can convert them back into equations with the x's, y's, and z's. And of course, you can start by solving for z by dividing both sides by 13 to get z equals 1, which means then you can take that answer and plug it into this second equation to figure out that y equals 2. And then take both of those answers to plug it into this equation and then end up solving for x to get x equals 2. And so the final answer in an ordered triple, x is 2, y is 2, z is 1. Numbers 3 and 4, you're going to use this as your original matrix A and your original matrix B. So this just means 3 times A, that's a scalar, times matrix A. So 3 is the scalar. Again, here, the scalar would be 2, and we're multiplying by matrix B. All that means is to do 3 times matrix A, we're going to multiply, well, might as well show the whole thing, whatever. So this is basically 3 times all of matrix A. We're going to multiply all the numbers in matrix A by 3 to get these numbers. And doing 2 times matrix B, we're going to multiply all the numbers in matrix B by 2 to get these numbers. So this is what I got. And then I can proceed to do the adding. And I can only add these two matrices together if they have the exact same shape, which they do. This is a 3 by 2, and this is a 3 by 2. So all I do to add these two matrices together is add the corresponding elements. So 15 plus negative 4 gets me 11. 12 plus 0 gets me 12. 3 plus negative 2 is 1. Negative 6 plus 12 is 6. Negative 9 plus 8 is negative 1. And 0 plus 4 is 4. And that's how that cookie crumbles. Same exact thing in number 4. Ooh, blue. Go Bison. So really just matrix A stays as is. And we're going to subtract the result when we do 3 times matrix B. So again, it's just a scalar. If we multiply all the numbers in matrix B by 3, we get this brand new matrix. And just be careful with your signs. Keep track of your minusing negatives and stuff, okay? Because this would be 5 minus a negative 6. That's the same as doing 5 plus 6, right? 5 minus a negative 6, you get 11, okay? Sorry, that's done. So now we do 4 minus 0 to get 4. Again, we just like over here, we're just going to subtract the corresponding elements, okay? So we're going to do 1 minus a negative 3. Yeah, 1 minus negative 3, that makes 4. Negative 2 minus 18 to get negative 20. Negative 3 minus 12 to get that. And then 0 minus 6 to get that. And that's the final answer for number 4, this matrix. Final couple of questions is about multiplying two matrices together. And when you're doing that, it's important to notice that this matrix A is a 2 by 3, and this matrix B is a 3 by 3. And so when you look to do matrix B times matrix A, like if you had matrix B on the left times matrix A, the inner dimensions have to match, which they do not. So doing matrix B times matrix A in that order, again with matrix B being on the left, with matrix B being on the right, the inner dimensions do not match, and so doing this particular multiplication would not be possible. But doing matrix A times matrix B with A being on the left and B being on the right, now these inner two dimensions match. So this will be possible. And furthermore, the answer matrix will be whatever the outer two dimensions are. So the outside dimensions, the 2 and the 3, that's actually going to be the shape, the order of our answer matrix, our resultant matrix. And so here's how we do this. We would do rows, like entire rows, times entire columns, just to get one number. So we have to do this entire row 1 times this entire row, sorry, I might as well just say that again. So sorry, let me say that again. We're going to do this entire row 1 times this entire column 1 just to get this number. So here's how you do it. 2 times 2 plus 0 times 0 plus negative 3 times 1. So it's like the first number times the first number, second number times the second number, third number times the third number, and you add them all together. 2 times 2 is 4. 0 times 0 is 0. Negative 3 times 1 is negative 3. So we had 4 plus negative 3 to get 1. And that's how it works for all these numbers that you get. Okay, we're going to do row 1 times column 2 to get negative 8, because 2 times negative 1 is negative 2. 0. 0 times 4 is 0. Negative 3 times 2 is negative 6. So it was basically negative 2 plus 0 plus negative 6 to get the negative 8. And then to get the 16, we do this row times this column. So it's kind of, like it makes perfect sense how when you do row 1 times column 3, your answer goes in the row 1, column 3 spot. See, this is row 1, column 3, this spot right here. And when you do like row 2 times column 2, you're going to get the row 2, column 2 position spot. Okay? And so that's how you let this play out to get this final answer. I'll just do one more, like when we do row 2 times column 3, and maybe I'll also add that it helps to write down numbers off on the side. So I'll do that for how to get like this, this final number of 19, which we're doing row 2 times column 3. Okay, so what color should I, let's go with orange. So here we go. We're doing 4 times 5, which is 20. Then we're doing negative 1 times negative 3, which is 3. And then we're doing 2 times negative 2, which is negative 4. So it's really 20 plus 3 plus a negative 4, and that's where the 19 comes from. And you can write down this little side scratch work for basically getting all of these numbers, the negative 8, the negative 4, the 10, the 16. But this is your final answer, right, cha. Okay? That's it.